Hello my PU2 champions, is the rapid revision over for the chapter determinant? Now it's time to solve those questions where you lose maximum number of marks. Even though these problems are worth only 1 mark, the category is 1 marker for determinant, whether it is MCQs or whether it is your fill in the blanks. Questions are each worth 1 mark, but you end up making a lot of mistakes and you lose marks like 5 marks out of 20, 10 marks out of 20. Have you ever felt this way? Are you among one of those students that get 5 out of 20, 13 out of 20? Yes, even though these problems are very simple. I know you have learned NCERT and these questions are very much direct from the NCERT when it comes to PU2 boards. Okay, let's crack all these questions. So today I've taken 20 plus most important problems, 1 marker problems. If you solve this, you will be completely prepared for the chapter determinant. Okay, let's start the session right away. All right, so have a look. As I said in the session outline today, 20 plus question, top 20 plus most important problems from which chapter? From the determinant, for the point of view of your midterms. Okay, let's see. Question number 1. I want all of you to please let me know at the end of the session how many of you got it right. Let's say somebody got 15 questions right, somebody got 12 questions right, somebody got out right. Okay, so you have to tell me how many you got it correct. Let's start with the question number 1. It's based upon the properties A equals to KB. We're looking for determinant of A. This is a property, K comes out, B is here, this comes as N. Okay, B is not going to be in the bracket, it's going to be in the determinant. My mistake. Yeah, B is like this, a K power N comes, right? What is N? N is the order. So K power N, determinant B, option B is correct. Question number 1. Okay, it's a direct property, you don't have to remember any of this. It's a direct property, it's a formula that you end up using in a lot of problems, even in KCET as well. Okay, very important property of determinant. Let's move on to question number 2 now. Question number 2 is coming up. Now it's here. 3x, x1, 3, 2, 4, 1. Sir, x equals to 2, x equals to 4. Doesn't make sense. Is it the way to do it? Is this how we solve this question? If I were in your place, no, I would have been that student who will go like this. Okay, but don't be like me, be better than me. What are you gonna do? This is not matrix. The correct way is, this is not matrix, it is determinant. Yes, when we say there are 2 matrices which is given equal to each other, whenever we have 2 equal matrix, corresponding elements are same. But in determinant, no, that's not the case. You have to find determinant over here and then equate it. Please check. 3 into 1 minus x into x equals 3 into 1 for the second one, minus 4 into 2. I get 3 minus x square equals to 3 minus 8. Bring on this side, it will become minus 5, right? So it will become 3 plus 5 equals to x square. I think I know all of you know how to calculate, right? Yes. So x square is 8. It means x value will be 2 root 2 with a plus minus sign. Correct, because you have basically this will come out as root 8, right? Root of 8 means what? Plus minus root 8 means plus minus 2 root 2. That's why the answer I've taken as option D. Option D is correct. Option D is correct. Question number 2 is also over. Moving on to question number 3. So 3 is what? It's a 3 cross 3 matrix. Okay, they're saying 3A is equal to what? 3A in determinant, the property is there, 3 power n, determinant A. What is n here? N is the order. In this case, order is 3. So 3 power 3 determinant A means 27 times determinant of A. That's my answer. But I have to find determinant of A as well. Check this out. I can find across my first column. Why is that? Because of course number of term which is 0 is higher in the first column. So let's find across the first element. We'll have 1 times of 4 into 1 is 4 minus 0. Answer is simply 4. Put it here. You get 27 times of 4. Answer will be what? 108, right? D. Answer is 108, D. Correct. This is determinant value across column number 1. Simple problem, property and determinant involved. Question number 4 now. Which of the following is correct? Okay. Determinant definition they're asking, right? It's about definition of determinant. So unique number. Okay, this is the correct one, right? Option C. Please check. Determinant is a unique number associated to a square matrix. Okay. These are incomplete. Option A and option B are incomplete. Combine them, you get option C. Question number 5 now. Adjoint of a matrix A equals to 2, 3, 1, 4. Adjoint they're asking. How do you find adjoint? Find the minor and then you check the sign of it. Okay. So basically, for this element, what will happen? For this element, you'll have this, because you're going to eliminate this row and this column, you'll have this 4. So 4. And this element is what? A11. 1 plus 1 is even. The position is called as A11. Position is even, hence sign change will not be there. For this element, again, if you go like this, you're going to eliminate these two, you'll have the answer as 1. And the position of that is what? A12. 1 plus 2 is what? 1 plus 2 is odd, hence the sign change will become -1. Okay. Same come for this point 1. You're going to eliminate this row and this column, you'll have only 3 left. So right here 3, and that is position A21. Again it is odd, so sign change as -3. The last one will be 4. For this element 4, you'll end up eliminating, please check, the second row and second column. You have the value left as only 2. So right here 2, the value is for the element A22, which is 2 plus 2 is even, hence sign will not change. So my value of adjoint of the matrix A, adjoint of the matrix A is given like this: 4 minus 1 minus 3, 2. 4 minus 1 minus 3, 2. Okay. We have to take the transpose of this, right? Yeah. You take the transpose of this, no? So we'll have the answer as, please check, option D. Next up, question number 6 now. Right? 6th one. Okay. Previous one is clear, right? You find the minor of that, you find the adjoint of that. You want a matrix adjoint, so you have to find, basically you find the cofactor first. These are the cofactors, no? These values were cofactor. Okay, how do you find that? Remember, you do -1 I plus j times mij, that is my cofactor. Remember, for any element aij, you find the cofactor, multiply with the minus sign if it is odd. Okay, and then what happens is you take that into the matrix and take transpose to get the adjoint, right? All right. Or in this one we have a sort trick also. What's the sort trick? Interchange the element. Okay, so this is given as 2 4 3 1. Interchange these two, it will become 4 2, and sign change, it will become -3 and -1. Answer is D. So either use the sort trick, okay, to find adjoint, but trick will only be valid if it is, MCQ. Otherwise you have to do the entire process as I have done. But this is 1 marker, right? You can use the trick. Okay, what is the trick? Across diagonal, interchange. Okay, across the other element, what happens is only sign reversal or sign change. Only sign change. Got it? That is the trick to find the adjoint of only 2 cross 2 matrix. Question number 6 now. Yeah, if A is an invertible matrix of the order 2, yeah, it's a property, right? Again, okay, this is a property. 1 upon A, sorry, not inverse, 1 upon determinant of A. 1 upon determinant of A. That's your answer. So option B is the correct choice. These are the properties, okay, but yes, they are very much relevant. It can be asked in the examination. So please, either this property will be asked or question on this property can be asked. So both the cases you have to remember the property. Okay, very good. Question number 7 now. If A and B are invertible matrices, then which of the following is not correct? Not correct, very important. correct. Okay, I think this is incomplete, right? Yeah, no, the correct only. Invertible matrices, okay, it means they have to be both. What it means is non-singular, correct? No, very good, very good. If they are both invertible means they have to be non-singular, so this is also correct, D is also correct. Okay, this also is correct, correct. That's my answer. This is the false one because this has to be determinant. Please check. This is the right choice, that's the wrong one. Okay, question number 7, option A is the right choice, which is false statement. Okay, I'll remove some extra markings from here. Please check. I'll erase all of this. Okay, the choice is the option A. Option A. Let's move on to question number 8 now. Yes, so question number 8 now. What it says, okay, we have a variable here lambda and inverse exists. It means, of course, this matrix is non-singular, means non-zero. Let's find the determinant now. What we get, determinant of this will become, can find across this particular column. So for 2 we'll have 6 minus 5 into 1 is 5. Okay, 0 we don't have to do, so that is simply minus 0 plus 1. So for this will be cancelled. 5 into lambda is 5 lambda and 4 into 2 is 8. We have minus sign means plus 8. I know all of you know how to find this calculation of determinant, right? This is clear, no? Okay, this is 2, 6 minus 5 is 1, and this is simply 5 lambda plus 8 not equals 0. Okay, what I get, 5 lambda plus 10 not equals 0, not equals to minus 10 minus 2, lambda not equals to minus 2. Option C is correct. Option C is correct. Question number 8, option C is correct. Let's move on then to question number 9. Sorry bhai. Question number 9. Inverse of a matrix. Again, this is 1 marker. I can use the trick. First thing is, we know that inverse is given by A inverse equals to adjoint of A upon determinant of A. And we have to find determinant of A first, and this should not be equal to 0. It has to be a non-singular matrix. You all know that very well. Let's find determinant. What do you get? Determinant of A is coming equals to 6 into 2 is 12 minus 4 into 3. Okay, this is coming as 0. Equal to 0 means the determinant value, sorry, the inverse value does not exist. For the inverse to exist, it must be a non-singular matrix. In this case, it is not. It is a singular one. Please check. Question number 9 is done. Question number 10. So yes, the questions from this chapter, whether it is matrix or determinant, will be of simpler kind only. They will not be very much difficult. So this is where you can score marks. Okay, chali. If area of triangle is 35 square units with vertices 2 minus 6, 5, 4, K 4, then K is what? Formula is there. Okay. 35 equals to 1 by 2. Write this. 2 minus 6, 1. 5, 4, 1. And we have last one is K 4 and 1. Okay. Now move on this side. We get here 70. Determinant, if you find, let's find determinant, and when you do that, because it's an area, right? So even though it was value was coming as negative, answer will turn out to be positive because the area has to be taken in the only positive sides. Sorry, need to have some water. Okay, 70 is there. Next up, please solve this determinant value. So we'll have both plus minus sign over here. Solving this will give me what? I can solve across the first row itself. We have 2 times of 4 minus 4, that is gone. That is 0, right? 4 minus 4 is 0, gone. Next up will be minus of minus 6 times what? You can remove this row and column. So column number 2 and row number 1. We have 5 minus K. We have 5 minus K. All right, and the last one will be plus 1. We'll have 20 minus 4k. 20 minus 4k. This is 0. We get plus minus 70 plus 6 times of 5 minus k. Okay, and 20 minus 4k. Let's simplify this. 30. Okay, plus 20 minus 4k. Let's continue. We have plus minus 70 over here. So we have 50 minus 10k. 50 minus 10k. Okay. 50 minus 30 plus 20 is 50. Minus 6 minus 4 is minus 10. Okay. So 50 minus 10k. So we have two conditions over here with the plus sign and minus sign. 70 equals to 50 minus 10k. This side, I get 10k equals to minus 20, k equals to minus 2. For this side, what I get? Minus 70, 50 minus 10k, this side, 10k equals to 120, k equals to 12. Check this out. Right? Am I right? Minus 2 and 12. Guys, please cross check. I might have made a mistake in calculation. Okay? Please check. And let me know in the comment section if I've made any mistake. I've tried not to, but I might also. Okay, question number 10 is done. Question number 11 now. Okay, now this is statement wala question. Matrix A is given like this is a singular matrix and square matrix. Okay, this is true. Let's check for this part first. Singular means, okay, I'll check for this. So for 1 I get what? If I do across my first column, I'll get 1 time of 2 minus 1. Okay, and then I'll get minus 1 time of, for this element, I'll have this and this cancel. I get 2 minus 1 again. If you check, this will become 1 minus 1. Answer is 0. So determinant of this is coming, determinant of A is coming as 0, and that is true. Okay, so both the statements are true, and it actually explains it, right? Option B is the right answer. Correct, no? Since the determinant value of the matrix A is coming equal to 0, that's why it is actually singular matrix. That's how we define a singular matrix. Okay, so I hope this is very much clear. If you're not clear with the calculation, solve it on your side. Check determinant is coming as 0 or not. Question number 12 now. Question number 12. Association reason. If A is a square matrix of order 2, determinant of A is 3, then adjoint of A equal to 9. Okay, is it possible? It's order 2, right? Property is adjoint of A determinant is given by determinant of A power n minus 1, right? If we had 2 adjoint, we'll put n minus 1 power 2. Correct, now? That's the property. Alright, no problem, sir. But in this case, this order is given as n is given as 2. If n is 2, this will become what? Determinant of A power 2 minus 1. How much is that? Determinant of A, that is given by 3. But they are saying this is equal to 9. It means assertion is false, right? Assertion is false, sir. What about reason? If A is a square matrix of order n. Yeah, this is the property. This is the property I used. Please check. Same thing. So R is true. Option A is correct. A is false, R is true. Okay, simple, right? Question number 12 is very, very simple. Moving on to question number 13 now. 13th, okay. Again, a statement based question. Statement number 1 says A is a square matrix of order 2. Determinant of A is 7. Then 4A is 1, 1, 2. Let's check. This property we have to use. This will become what? 4 power n. Determinant of A, 4 power n is what? 2. Determinant of A, 4 power 2 is 16 into, this is what? 7. We get 2 here. Correct. That's right. Same property, correct. So both of them are true. Okay, both of them are true in this case. So 1 is true, 2 is true. Option C. Both of these are correct. 13th, both of these are correct. Please check. Okay. Be a little patient. Read the statement properly. You get the answer. Get that 1 mark and move on to the next question. Okay. You have to save some time in the MCQs. That's why You have to be quick and accurate in these. That's why we are doing so much practice, right? Every chapter, one marker, we are giving preference because we understood, yes, you all need that help. Okay, and they carry a lot of marks, 20 marks, right? Very important. Moving on. Question number 14 now. Inverse of matrix does not exist. Let's check. Yeah, correct, no? Because this is going to be 0. Determinant of A is 0. 6 into 2 minus 4 into 3 is 12 minus 12, which is 0. Okay, and it has to be a non-singular to say that inverse exists. Hence, it is a non-existing in nature. Statement number 2 is inverse of a singular matrix does not exist. Correct. Both of these are true, and actually explains the assertion also as well. Okay. Statement 2 is true, 1 is true, and 2 explains the statement 1. So 1 is true, 2 is true, and correct explanation. So it means option B is right. Option B is right. 1 is true, 2 is true, and statement 2 is the correct explanation of the statement 1. Okay. So 14th is done. Question number 15th now. Okay, is a square matrix of order 3. N is given as 3. What next? Determinant of A is also given as 3. Aij is a cofactor of Aij. Correct? Capital A is what we represent for the cofactor. Small aij represents the elements of the matrix. What are they saying? A21 multiplied with, okay, this is something we all know. Okay, A13, A23. Please check. Is it the same? Is it the element and its same cofactor? Because we have learned two different things over here. Element and its own cofactor when multiplied in series like this. Summation of Aij, okay, and Aij. From where to where? Ij belonging to 1 to n, right? Correct, no? Whether it is A12, A13, like that, whatever is the element, you add them, you always get what? You get this. We have learned this. You get determinant of the value. But if you multiply any element with different or any other cofactor, what happens? Result is something. Always 0. We have learned that if you multiply an element with some other element's cofactor and take the sum like that, you will have the result as 0. If you multiply the element with its own cofactor and take the sum like that, then it becomes equals to determinant value. Question number 16 now. Question number 16. If A is invertible matrix of order 2, then A inverse equals to what? This is a simple question. A inverse is given as I. Apply determinant on both sides. Answer is 1. A inverse is I. Determinant of an identity matrix is always 1. Next up, we have okay, if A equal to 1, 1, 17th question, 1, 1, 3, 2. 280 is what? 280 is what? Determinant. So first 2 will come out. 2 power 2 will become. How come, sir? Correct, na? 2 power n. N is 2 in this case. Order is 2. So 4. 80 is same as determinant of A. In determinant, transpose does not matter. Value will remain unchanged. Find this value. 2 minus 3. 2 into 1 minus 3 into 1. What do you get? 2 minus 3. Answer is 4 into minus 1. Answer is minus 4. Answer is minus 4. Clear? Clear or not? Yes? Yeah. They are simple. They're supposed to be simple. If you have learned all the concept, if you learned from me, of course they'll be simple. That's why I'm putting, so much effort, right? So that things are simpler for us, so that the questions are simpler for us. If A is a square matrix such that A square is I, okay, determinant of A is non-zero. A inverse is equal to what? Superb question. This is a good question. You might skip this problem. I'm looking for value of A inverse. And we have only this given. It means I have to make one of these as A inverse. Simple, we can do that. First, why would I do that? Think about it. I'm looking to find the value of A inverse. Question, that is what they're asking us. A inverse equals to what? Right? That's what they're asking us. A inverse equals to what? Okay, they have given us 4 options. They're saying A square is equal to I. A is non-zero, means inverse exists. Okay. Then they're asking us to find A inverse. It means I have to make use of this equation, and one of the side has to make be what? To have to make A inverse. How can I do that? Multiply A inverse on both sides. Check. Because A inverse into I will become A inverse. This will become A into A. This is I. I into A equals to A inverse. A equals to A inverse. And we have answer as A. Option C. Question number 19 now. Yes. Question number 19 now. 18th is done. Simple. We have to get A inverse on either of the side. We got it by multiplying on both sides by A inverse. Answer is A inverse into A is I. Hence, A inverse equals to the A value. Option C is the correct choice. 18th is done. Question number 19 now. Okay, determinant of cos is given, cos sine. Do one thing, find the determinant. We get cos square of 15 minus sine square of 15 degrees. There's a formula. Cos square minus sine square is given as, there's a formula. Cos of 2 times of 15. Cos 2 theta formula. Okay. Yes. It becomes cos 30 root 3 by 2. So you have to remember formulas. They can be interchanged. They can be asked anywhere. Okay. You can't say that, sir, this is not there in the syllabus. It is there. You've learnt in PU1, haven't you? Formula of cos 2 theta. Cos 2 theta. Cos square theta minus sine square theta. Okay. Done? Yeah. Question number 20 now. Alright. If A and B are square matrix of order 3 such that determinant of A is minus 1, B is 3, then 3AB inverse is equals to what? Okay. 3AB inverse will go like this. 3 will come out. A, B inverse, what is the value of power of 3 will go with? Order is 3, right? So 3 power 3 will become 27. This is given as minus 1. Minus 1. This will be what? 1 upon determinant of B. Minus 27 by this value is how much? 3. What I've done over here? Nothing, just using the properties. Property of multiplying a scalar to the matrix, then taking determinant. Okay, scalar comes out with the power as order of the matrix, and then if you have the product and looking for determinant, you can separate the terms as well like this. Determinant of A into determinants of B inverse. Again, this is the property. 1 upon determinant of B. Answer is what? Minus 9. Minus 9, option A is correct. Question number 20, option A is correct. Question number 21, let's solve now. 20 is clear. Okay, 21 now. 21. The system of equations given like this has, check the ratio. It's a straight line, right? 4 by 8, 6 by 12, minus 5 by minus 10. 5 will come over here, 10 will come over here, it will become minus 5 minus 10. 1 by 2, 1 by 2, 1 by 2. They are all equal. It means it is coincident line. They are coincident line. It means they'll have infinite solution. They'll have infinite solution because they are coincident line. It means overlapping in nature. They are overlapping in nature. Okay. Done. Now this is the last question of the day. Let's solve this and complete our session on the chapter determinant for 1 marker category. Let me know what you felt about the session, about these 22 questions. Were they fun? Were they different? Were they something that you're looking for? If I missed something, you have to let me know in the comment section. I've tried to give you all varieties of questions from this chapter. But yeah, if I missed something, you can let me know. If A is 1, 3, 4, 2, B is 2, minus 1, 1, 2, then find this value. Okay. Now we all know how can we break this. AB B dash becomes A times of B times of B dash, A times of B times of determinant of B, because determinant, transpose or simple matrix will have the same value, transpose doesn't matter. I get determinant of A times of determinant B square. Find the value from here. How much is it? We get here 2 minus 12 minus 10, 2 into 3 minus 4, 3 into 4 is 12, so minus 10, and B will be 4 minus of minus 1 into 1, so 5. Answer will become what? Minus 10 into 5 square, minus 10 into 25, so minus 250. Minus 250 is the answer for question number 22. Please check. Minus 250 is the answer for question number 22. Okay, so with this, session is over. This was the last question that I wanted to solve. If I missed something, you can always let me know in the comment section. I'll try to come up with more questions in the other sessions, okay? But I've tried to give you all the varieties that is possible in the chapter. So this is it for the session. I'll again see you in the next segment of this chapter of determinant, okay, whether we're gonna solve subjective questions. So stay tuned for that session. This is it for this video. See you again very soon. Till then, take care. Bye bye.